Kinetic particle theory, a summary. Kinetic particle theory describes the states of matter, or solids, liquids, and gases. Solids have properties such as having a fixed shape, having a fixed volume, they cannot be compressed, and particles are closely packed and vibrate about fixed positions. While liquids have properties such as having no fixed shape, no fixed volume, they cannot be compressed, particles are less closely packed compared to solids. Their particles are able to slide past each other in the body of the liquid. While gases have properties such as having no fixed shape, no fixed volume, they can be compressed, and particles are far apart and travel at high speeds in random directions. So, if we heat a solid and it turns into a liquid, we call this process melting. And if we do the same for a liquid and it converts into a gas, we call this process evaporation or boiling. So if we heat a solid so much and it goes straight into a gaseous state, we call this sublimation. So when heating and inducing a change of state, particles gain thermal energy, moving faster and further apart. They overcome the forces of attraction holding them in their previous positions. So now that we know what happens when you heat a state of matter and it converts to another state of matter, we understand its particles and what it does. What if we do the opposite of heating and induce a change of state? We call this cooling. So if we cool a gas and it converts into a liquid, we call this process condensation. If we cool a liquid further and it becomes a solid, we call this freezing. So if we cool a gas so much and it jumps straight into becoming a solid and skipping the liquid state, we call this deposition. So when cooling and inducing a change of state, the particles lose thermal energy, they move slower, and they are pulled closer together by the forces of attraction between them into their new, more rigid positions. So now that we understand what happens when we heat and induce a change of state, and what happens when we cool and induce a change of state, we can now use kinetic particle theory, as it also explains what is diffusion and how the rate of diffusion is affected by temperature and molecular mass. So, the rate of diffusion increases with high temperature, or for diffusion of gases only, has a lower molecular mass. So if a gas has a lower molecular mass, the rate of diffusion of that gas increases. The same can be said when the rate of diffusion decreases with a low temperature or when the gas has a higher molecular mass. This can be explained as a gas that has a high molecular mass requires more energy to move across the same distance as compared to a gas with a lower molecular mass requiring less energy to move over the same distance. So a gas with a lower molecular mass would diffuse across the same distance faster than a gas with a higher molecular mass. And with that concludes Kinetic Particle Theory, a summary. And I would like to thank you for watching. Do leave a like and remember to subscribe. See you next time. Check out my other videos here.